For today's video, we're going to be using the definition of derivative to determine f prime of x. And just like with any concept, we have to have an understanding of how to say the definition, because having that language will help us understand the concept, especially when we're talking about mathematical terms. And as you can see, the definition of derivative is more of a mathematical formula. So this is how I like to say the definition of derivative. The derivative of f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Technically, what the derivative is helping us determine is how fast a function is increasing or decreasing at any value for x. And if we were to just go along this function, as we go from left to right, we can see that we're increasing here, and then all of a sudden we start going to the other side and now it's decreasing. We are determining what the rate of change is at each one of those points. And then visually, we can look at it as, well, what are the slopes of the lines that are tangent at those points? Doing this graphically is not going to be the best use of our time. We need to be able to determine the derivative of f of x in a more factual way, with a more algebraic process. Now, we're going to use the same graph that we were just looking at, but the function for that graph is negative 3x squared minus x plus 1. And to take our function of f of x, we're going to use our definition of derivative to find the derivative of that function. And the reason we want to do that is because we could then very easily plug different points in for x and be able to determine what the slope of the tangent line would be, or how quickly at that point the function is increasing or decreasing. And to do that, we use the definition of derivative. The definition says f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Anytime I work with the definition of derivative, I always break it up into three different parts. The first part that I look at is my f of x plus h, and then from that I am going to subtract the f of x, and then all of that divided by h. And by kind of breaking it up like that visually, then mentally it makes it a little bit easier to look at it in those same components. And having done math for quite some time, there's just some helpful little hints that I can give you along the way to make sure that that algebra stays intact the entire way, because the definition in itself really isn't that complex of a concept. But the algebra that we have to do within the process, that can get a little bit confusing, so we do have to be able to keep track of it. Okay, another hint I'm going to tell you is don't leave out these little parts of it. Don't leave out the limit as h approaches 0, or the other part that gets left out a lot is divide by h. It gets put back in later. But the thing is if we get in the habit of taking things out, sometimes we forget to put them back in, and that can cause some problems with the math. All right, so starting out, we're going to look at f of x plus h. And all that's telling us is we're going to take our function of f of x, and we're going to put the quantity of x plus h in for each one of those x's. And we got to make sure we don't leave any of those parts out. So we have negative 3 quantity of x plus h. Remember that's squared, and then minus the quantity again of x plus h. And don't forget the plus 1. That gets left off quite often. That entire expression right there, that in itself is just what f of x plus h is. Now from that, we are going to subtract f of x. So we're subtracting that function as it is. So minus 3x squared minus our x, and then plus 1 in your parentheses. And now that is your minus your f of x. We're not going to change the signs in anything until we get to that point. Okay, that's just one of those things that when we start kind of changing things here and there, then it can get a little bit confusing as well. And then don't forget the divide by h. That's going to be an important one. It's going to be later on, but it's very important. Now we are pretty much just based on figuring out what our simplifying that numerator so that we can do a little bit more work with it. And this is where the algebra comes in. I chose a function that was a little bit more complex than just a basic quadratic, because it's those signs that usually give us problems along the way. And so this way we can kind of look at it and watch how that all plays out. All right, so simplifying this, we definitely have to be able to take that top part, the x plus h, and square it. We can't do anything with that -3 yet because of those order of operations. And this is one of those algebra reminders we need to make sure and have. When you take x plus h and square it, we've got to remember that we are taking x plus h times an x plus h. We have to FOIL this problem out in order to get the appropriate answer to it. Sometimes we get to go in a little bit fast and we forget that there's a process to this. So when you do that, this is where our first gives us our x squared, and then our outside gives us our h times x, and if you put xh, doesn't matter, same thing, just keep it consistent. And then again, your h times your x for the second one, and then for the last is where your h squared comes from. By doing that, these two in the middle gives you your 2hx. And so that is where we are going to have to include that in our next step of the problem. So we have our -3, and then our x squared plus 2hx plus h squared. We continue on with our minus x minus h, and then plus 1. And now we can distribute that negative for the minus f of x. So it becomes plus 3x squared plus x minus 1. And don't forget the all divided by h. Okay, this is where we kind of talk about the fact that it can start getting a little bit jumbled up and a little bit harder to see, but if we can mentally maintain those sections, then it allows us to kind of be able to check ourselves along the way to make sure we didn't miss any of those parts. All right, simplification, just continuing on. The limit as h approaches 0, now we can distribute -3x squared minus 6hx minus 3h squared. And I know just a portion of this can be simplified, but for explanation's sake, we're going to go ahead and write it out this time. And then that's all over h. Okay, continuing on, same. There's the first part, there's the second part, just mentally, and you don't have to highlight it. It's just for you to mentally to look at the separation of those things. All right, now here's where the magic happens. This is where we simplify things a lot. So as we go through, we're going to look for our terms that we can put together. And you might notice that we have a -3x squared, but we also have a positive 3x squared. Those two are going to cancel each other out. And as we make our way through there, we have a minus x and a plus x and a plus 1 and a minus 1. And all we're left with is 3 terms now in the numerator. And if you look at those 3 terms in the numerator, those all have h's in them. So that is going to be kind of the pattern that you look for. If you know you did it correctly, if those things cancel out and you are left with just the terms with the h in it. So -6hx minus 3h squared minus h, all divided by that h. Now again, just an algebra reminder, when you are doing this, I'm just going to show it here. That doesn't mean you have to write it down if you know this process. And when you divide by a monomial like that, you just take each one of those terms and you divide it by that h. And in doing that, then you're going to have the limit as h approaches 0 of, that cancels, you're left with a -6x, 1 of those cancel, so minus 3h, and then of course h divided by h is 1. So in this problem, when we are going to take our 0 and as it approaches 0, our h as it approaches 0, so here we have our h approaches 0. When that happens, that 0 times whatever it's being multiplied times, that whole thing approaches 0. So all we're left with is what f prime of x is. And f prime of x is equal to -6x minus 1. And if we were to look at our graph I'm going to put it right here, negative 6x minus 1. Any point that we choose on there, we are going to be able to find what the slope of the tangent line would be, or how quickly that function itself is increasing or decreasing at that very point. Now that we've found the derivative, we need to know how to use the derivative. And the derivative that we found for our function is f prime of x is equal to negative 6x minus 1. If we look at our graph of f of x, which is showing there in the green, if we were to follow this graph, we start down bottom left. We read graphs the same way that we read sentences. Always go from left to right to be able to talk about what's happening with the behavior of the graph. Well, if we were to go start at the bottom left-hand side, and we are now going uphill, so we're increasing, and then, oh, we hit the top, and now come around, now we are decreasing. Well, when we look at that and think about what is going on at each one of those points, increasing, that's a positive value. Decreasing, that's a negative value. So we can find out how quickly it's increasing or decreasing at any of the points that we have. Now I'm going to choose 3 nice points because those are going to be easier to work with mathematically. So we have right here where x is equal to a negative 1, and follow it around, this is where your x is equal to 0. And then a little bit further down, we are going to have where x is equal to a positive 1. If we want to determine how quickly that function is increasing or decreasing, what its rate of change is at those 3 points, all we have to do is use our derivative to be able to determine what happens at negative 1, what happens at 0, and then what happens at positive 1. Those are the numbers that are important to be able to determine what is happening in each one of those points. And the quick math that goes with them, we're just plugging those things in. So we've got negative 6 times a negative 1 minus 1. That's going to be 6 minus 1, gives us a slope at 5 at that point. We plug in our 0, negative 6 times 0, obviously is 0, minus 1. We now have a slope of negative 1, and just like we said when we followed that graph around, we're like, oh, we hit the top, and then now we're going downhill, which is a negative slope. And then we get to our f prime of 1. Negative 6 times 1 minus 1 is going to give us negative 6 minus 1, and that's a negative 7. Definitely more steep where we were at x equal 1 than it was when we were at x equals 0. Now, this is not the only way to use the derivative. This will give us the slope at any point along the way, and we will be using that to find equations of lines and equations of tangent lines and things like that. But there's another way to use derivative that is extremely important that you are going to see later on down the road. And that is going to be where we have a very specific point. And when we talk about parabolas, we have an important point. It establishes location of the parabola. What happens on the left side of the point is a mirror image of what happens on the right side of the point, and which it also established in terms of the point. It's that line that cuts it in half. It's that axis of symmetry. And on that axis of symmetry, we always have this point. And that happens right here on this parabola. That is the vertex. Well, something happens very specific at a vertex or at the top of a hill or a bottom of a valley, because that changes from going uphill and then all of a sudden now, oh, we're coming down the other side. So now we're going negative. And what is the one thing that always is in between, or what you always have to cross between positives and negatives? And that is what we are looking at in terms of its tangent line. That tangent line is horizontal. And if we have a horizontal line, we know about the slopes of horizontal lines. The slopes of horizontal lines are 0. So if we can take a function, if we can take its derivative and find out where it's equal to 0, that's the other use of derivative that is extremely important. Not just finding the slope at every single line, but finding where specific slopes happen. So we would be able to take our function and set it equal to 0, and that is going to tell us where that important point happens. Where is the axis of symmetry at, what cuts it in the middle, and then where that vertex of this parabola is going to be. So we just take our function of negative 6x minus 1, set it equal to 0, And then a little bit of quick math says we're going to, the little bit of math says that we're going to get -1/6. So axis of symmetry of this parabola is going to be at x equals -1/6. Then we know that because we looked at that vertex and said right here is where our slope is equal to 0, and that's going to cause us to have an important point. The definition of derivative is the basis for all differentiation, and we have to have a good understanding of the basics before we can expand on them. And that's why with this section we have to be able to look at the algebra. We have to get an understanding between what you start with your function and what the derivative is going to be. And the only way that we can get there is if we practice. So for right now, practice makes perfect.